Okay, this is video 5 and we are beginning with chapter 21. We are talking about variance. In this video, I'm going to talk about analyzing a random experiment and the motivation behind variance. Let's look at what we have talked about until now, ever since we started talking about probability theory. So the first thing that we talked about was experiment, right? So we looked at experiments. And then we knew that these experiments could be random, right? And then these experiments led to something called outcome. And outcomes can be complex, right? And then maybe we were interested in certain events and we came up with those events and calculated probability, right? But then we came to know of a better way of summarizing these outcomes, some measurable X, right? So if we could measure X, that was a random variable, right? And then we thought of summarizing the information that the random variable is essentially telling us through PDF and CDF, right? And so we were interested in the summary, and that summary was achieved by finding the expectation for X, right? Now we are interested in understanding how good my E of X or my summary is, right? Because as we saw, using like our definition of E of X, right? We know that there are certain assumptions that underlie that E of X, right? So we want to understand how good my E of X is, right? Let us consider this experiment in which I'm rolling n dice, right? And I'm interested in computing X, where X is the average of n rolls, right? So I'm defining my random variable X as the average of n rolls, and then assuming it's a fair dice, right? So I'm interested in E of X, right? Now X is the average, right? So which is actually the expectation of 1 over n times sum of all these n rolls, right? Which is essentially, now going back to part B of our linearity of expectation, right? This is just a constant, right? So this is 1 over n times the expectation of sum, right? And then we know that the expectation of sum is going to be n times the expected value of each x1, x2, x3, and so on. So I'm like just summarizing that now, I'm not repeating that. And this was calculated in one of the problems earlier, or even now we can calculate it. And this is equal to 3.5, right? So for E of X, the expected average of n rolls is 3.5. And notice it's independent of n. Okay, so essentially we're saying that the expected average for rolling of n dice is 3.5, right? But let's look at a few experimental values that are associated with this experiment, right? So let's look at this slide here, right? So this one here shows the observed averages, right? So this is showing the observed averages against the number of times the dice was rolled, right? Or independent dice rolls and independent dice rolls. And the observed average, as you can see, with when n is smaller, for example, 1, and then it increases to 2, and even up to 10, you can see that it is showing a lot of fluctuation from the expected average, which is 3.5. Right, so that is my expected average, but the observed average shows a lot of fluctuation initially, especially for smaller ends, but then for larger ends, as the roll of my dice, the number of times I'm rolling it increases, this really converges to the expected value that we calculated, right? Okay, a similar sort of trend can be seen here when I'm plotting the probability values or the PDF against the averages. The average for both cases, this is for the roll of n equals 4, and this is for n equals 100. right? So here I can see that the average here, the expected value is 3.5 for both of them. Why? Because we saw that in the example on the previous slide, it is independent of n, right? So the values are, the center is 3.5 for both of them. But as you can see with the 4 rows, when n is 4, there is a greater spread, right? And the spread is like between 1 and 6, like all possible values. Now when n increases, when n is 100, you can see that the spread is less and it's hardly between 3 and 4, right? It's not between 1 and 6 anymore, right? And also notice this parameter sigma, right? This is what we call it, which describes the width of the probability distribution, right? So the basic motivation behind variation is that how much the outcome can deviate from the mean, right? So this is my mean, and I'm interested in finding when will this deviation be this much versus when will this be this much, right? So how much is that spread? How much my outcome deviates from the mean? So we'll continue this discussion in the next video.